In the previous lecture, we talked about recurrence relation and sequences. We now have recursive function. We say many functions are defined in such a way that the value at one input is defined in terms of other values of the function. That means each input is defined in terms of the other values of the function. Here, in this type of function, this type of function is called recursive function. Here, we say this is recursive function. The function has this property. We say this function is a recursive function. We say a recursive function is a function that calls itself, invokes itself, okay? And also, we say a recursive algorithm. Here, this is the algorithm, this is the procedure. Generally, how it's working, how the function is working, is an algorithm that contains a recursive. And then recursive is a way that can be used to solve a large class of problems. That means if we have a large class of problems, we should use recursive function. For example, here we have factorial. For factorial, we say n factorial means n times n minus 1 times n minus 2 up to 1. Okay? Did you study n factorials? I mean, okay. For factorials, we say n factorial equals n times n minus 1 times n minus 2 up to 1. For example, here, 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. How about 5 factorial? Equals 5 times 4 times 3 times 2 times 1. Okay? This is factorial. If you have n factorial, we multiply it by all the numbers which are less than or equal to n up to 1. That means if you have 10 factorial, 10 factorial means 10 times 9 times 8 up to 1. We multiply these all numbers. Here, this is the general form of factorial. We say n factorial is n times n minus 1 times n minus 2 up to 1. And you also can say n factorial is n times n minus 1 factorial. How? If we have, let's say, 5 factorial. We say 5 factorial is 5 times 4 factorial. That's 2. Since here, 4 factorial is 4 times 3 times 2 times 1. That means if we multiply 5 to this one, we get 5 factorial. That means here, let's say 10 factorial equals 10 times 9 factorial. And 9 factorial is 9 times 8 factorial. 8 factorial is 8 times 7 factorial, and so on. Okay? This is factorial. To write down the algorithm, the recursive algorithm for this factorial, it's here. Actually, the algorithm is in the next slide. Here, if n to be 5, this is input. So what's the function? What's the output? The output is 5 factorial. If you want to find the factorial of n, means the input is 5, and the output is the factorial of 5, which is 5 factorial. So 5 factorial is 5 times 4 times 3 times 2 times 1, which is 5 times 4 factorial. You also say 4 factorial is 4 times 3 factorial. And 3 factorial is 3 times 2 factorial, and so on. Okay? So 5 factorial is 5 times 4 is 20, times 3 is 60, times 2 is 120, times 1 is still 120. That means 5 factorial is 120. Sorry. Okay. Here, we say for factorial of a number, first we should have the number. We should have the number. That means that's input. Okay. And what's the output? Is finding its factorial. That's the output of the input number. We say n equals 5. This is input. So what's the output? The output is 5 factorial. You study programming. Okay. In programming, we must have input and output. Okay. So the procedure is this. You see 5 factorial equals 5 times 4 factorial. Then 4 factorial is 4 times 3 factorial. That means this becomes 5 times 4 times 3 factorial. Is it? Because here we replace 4 factorial by 4 times 3 factorial. We said n factorial equals n times n minus 1 factorial. That's true. So here, 5 factorial can be written as 5 times 4 factorial. And then 4 factorial is 4 times 3 factorial. Then 3 factorial is 3 times 2 factorial. So you have 5 times 4 times 3 times 2 factorial. And 2 factorial is 2 times 1 factorial. And 1 factorial is itself. Okay? It's itself. 1 factorial is 1. So you get 5 times 4 times 3 times 2 times 1. This is the factorial of 5. In computer programming, it's working like that. It's working like that. Here, it's done step by step. N factorial is n times n minus 1 factorial. Then for other terms, we are going to find and we get 5 times 4 times 3 times 2 times 1. This is 5 factorial, and the result is 120. Sorry, it's 120. Look, this is 20. This is 3. This is 2. That's 120. That's how we find the factorial of a number. And here, to write down the algorithm for this function for factorial, how do you write? The input is n. This is the input. So what's the output? The output is n factorial. We should write down input and output. And then we are going to write down the procedure. We say factorial n is, we say if n equals 0, return 1. We say 0 factorial equals 1. And also 1 factorial is still 1. 1 factorial and 0 factorial are both 1. And we say the input must be a number which is greater than or equal to 0, and it must be integer also. That means a non-negative integer. It's a non-negative integer. So it must not be negative, and it also must be integer. Okay? Here we say the process is like that. First we write down the input. Then what's the output? The output is n factorial. We say factorial n, this is the name of the function, is, we say if n to be 0, return 1. Return 1. 0 is the last number that we get in the multiplication. Okay? That means if we have this 3 factorial, it equals 3 times 2 times 1 times 0. That's all. Okay. Times 0 factorial. Is it? And 0 factorial is 1. So, and we get this one. That's 3 factorial. We say if n to be 0, if the input is 0, return 1. That means 0 factorial is 1. What if this condition is not true? If n is not equal to 0, we say return n times factorial n minus 1. n times factorial n minus 1. It's the process that we said, n times n minus 1. Only return this one. Return n times n minus 1 factorial. This factorial. For factorial, we don't write down the exclamation mark in a computer programming. We just write down factorial. Okay, factorial n, that gives us the results. So this is the begin and that's the end. This is the program, the algorithm for the program to find the factorial of any number. First, we write down the input and the condition on the input. And condition on the input is a non-negative integer. Then output, and then we write down the function. In the function, if the input is 0, we say return 1. If it's not 0, return n times n minus 1. N times n minus 1 factorial. That's all. Now we have Fibonacci sequence. For Fibonacci sequence, we say the sequence is like this. F1, I mean the first term is 1. The second term is still 1. But the other terms, how they are working, we say the sum of these two is this one. And then the sum of these two is this one. And the sum of these two is this one, is the next one. The sum of these two is next one. The sum of these two is next one. That means Fn equals Fn minus 1 plus Fn minus 2. That means each term is the sum of the previous two terms. Okay, but here the first and the second term are both 1. يا كم ترم دوم ترم يك أي ترم كان كسين بيرتلا كود وترم بيش كود. Okay, here 2, this is the third term. This F3, F1 equals 1. F2 is still 1. How about F3? F3 is F1 plus F2, which is 2. And F4 is F2 plus F3, which is 3. And then F5 equals F3 plus F4, F3 plus F4, which is 5. And F6 equals F4 plus F5, which is 8. And so it's working like that. This is the Fibonacci sequence. This sequence is called Fibonacci sequence. Here we have the algorithm for Fibonacci sequence, a recursive algorithm for Fibonacci sequence. First, we have input. Input is n. It's the number that we want to find. I mean, the number of terms of the sequence. For example, if this is 5, that means we just find 5 terms in the sequence. If it's 10, we are going to find 10 terms of the sequence. But here n must be greater than or equal to 0, to 3, sorry. It must not be less than 3. It must be greater than or equal to 3, as it's written here. This is the condition on n. Yes. نابس كم تربيت سيانزات الشيشن. Okay. If let's say if n to be, let's say 4, that means F4. No, we cannot take less than 3. Look, here we say for n to be 4, what should you find? We should find F1, F2, F3, and F4. That's all. We just find 4 terms in the sequence. What are the first 2 terms? They are 1. They are 1. In Fibonacci sequence, always the first 2 terms are 1. This is 1 and this is 1. How about the third term? The third term is the sum of the 2 previous terms. 1 plus 1 is 2. And the fourth term is the sum of third term and second term. That means it is 3. That's all. We just find these. How about if n to be 6? We're going to find f5 and f6. What's f5? Is 5. The sum of these two. Yeah, 5. And then f6 is 3 plus 5, which is 8. And so that's for n. Here, we must have input and output in the algorithms. The input is n. How about output? Is fn. It's fn. So here, when we say n for n to be 4, that means what's f of 4? Equals to what? What's f4? What's f of 4? This is f of 4, which is 3. How about f of 6? It's 8. The last term is the value of the last term. How about f2? 1, yeah. How about f3? Yeah, that's it. Only the value of the term. That's it. So now, for the algorithm, we say input is n and output is f of n. F of n. This is output. This is the output. We name the program to be f of n. You can give any name to it. Okay? But here we name it f of n. We say if n to be 1 or n to be 2, what do we need to get? It's 1. That means f of 1 is 1. F of 2 is still 2. How about if n not to be 1 or 2? That means if it's 3, 4, or any other value, any other number. Here we say it equals f of n minus 1 plus f of n minus 2. That's all. It is, if it's not the first and second terms, it means it is the sum of the previous two terms. That means if it's n, let's say it's 10. Let n to be 10. What we get? We get f of n minus 1, which is 9, plus f of n minus 2, which is 8. That means it's f of 9 plus f of 8. Do you get that? That's so easy. Here, we just need to write down the general formula for the function, for the Fibonacci screens. Each term, except the first two terms, is the sum of the previous two terms. That means if it's n, it means it's the sum of n minus 1 and n minus 2 terms. So that's it. And it's an input. It could be any number, any positive number. Vale? نحن اللي راي بس الجوريثم كأنه ستاه يستر. الامتحان أو نائب لي أول شيء شلون أم برنامج إيش كان أو تكين بيوبل أو اشتوى نهته. بنيته على algorithm بنوسا أجر أما Fibonacci Screens bit. Write down the algorithm for it. Just write down the algorithm. If you can find this one, this formula, that's all. We talked about how to find the formula for screens in the previous lecture. If just find the formula, that's all. And here we just worked on the formula. If it's 1 or 2, it's still 1. But for other terms, it's we now have another example. In the example, we have given a sequence 1, 3, 5, 7, 9, and so on. So here, the formula for this sequence is, as you see, each term depends on the previous one. Each term depends on the previous one. What's the difference of the terms? It's 2. From 1 to 2, from 1 to 3, as you see, from first term to the second term, from first term to the second term, here we have 2. This difference is 2. And from 3 to 5 is 2. From 5 to 7 is 2. From 7 to 9 is 2. So the formula is, we say an equals an minus 1 plus 2. That's the formula. We say the difference of each two terms is 2. That means each term is the previous term plus 2. Each term is the previous term plus 2. That means an equals an minus 1 plus 2. You'll be given something like this. You may be given these, or you may be given only this one. So what in the case if we have given only the sequence? We first must find the formula. So the formula is an equals an minus 1 plus 2. That means each term depends on the previous term and then plus 2. This is the sum of previous term plus 2. This is the formula. To write down the recursive algorithm for this sequence, after finding the nth theorem, I mean the formula, we can write down the sequence. We say f of n. What should we find? We should find f of n. Okay, this output. And here you can say n, this input is n. The input is n. Then f of n. We say if n to be 1, always the initial condition is fixed. Always. Look here, the initial condition is the first term, as we talked about in the previous lecture. We said the first term is the initial condition. This is the initial condition. That means if n to be 1, return 1. So how about the other terms? We say the second term is the first term plus 2. The third term is the second term plus 2, and so on. We say return f of n minus 1 plus 2. That's all. And here it says use the above recursive algorithm to trace n equals 4. N equals 4. How this algorithm is working? We are going to work on it. Look. First, we say if n to be 1, return 1. If n to be 1, return 1. So if it's not 1, we are going to reduce the value of n one by one till we get 1. And then we return. Look. First, to trace n to be 4, we say f of 4. First, we have f of 4. N equals 4. This is the input. N equals 4. Since n is not 1, this is our condition. We say if n to be 1, return 1. So what if n doesn't equal to 1? Return n, f of n minus 1 plus 2. Yeah, n is not 1, since n is 4. That means we return f of 3 plus 2. As you see in the above one, it says f of n minus 1 plus 2. So if n to be 4, we get f of 3 plus 2 in the first step. That's it. And then for f of 3, n here is 3. So n doesn't equal to 1. We say if n is not 1, if n is not 1, we say we return f of n minus 1 plus 2. Here n is 3, minus 1 means 2. So f of 2 plus 2. We get this. Then for f of 2, we reduce the value of n one by one till we get 1. Till we get 1, till it satisfies the condition. The condition is, we say if n to be 1, return 1. So n to be 2, 2 doesn't equal to 1. That means we return f of 1 plus 2. Why? Because we say f of n minus 1 plus 2. N is 2. If it's 2, so you get 2 minus 1, which is 1. That means you get f of 1 plus 2. Then we have f of 1. 1 equals n equals 1. That means n equals 1. It satisfies the condition. If you return to the previous slide, we say if n to be 1, return 1. That means here, for n to be 1, return 1. That's it. Then, after returning 1, it returns to the above 1. Okay? Then, here, we return f of 2. F of 2 is 1 plus 2. Because this is f of 1 plus 2. F of 1 is 1. Plus 2 is 3. So f of 2 is 3. And then, for the next one, this is f of 1. This is 2. This is 3. This is the second term. So the first term is 1. The second term is 3. And the third term, f of 3, is 5. How? It is f of 2 plus 2. What's f of 2? F of 2, you found it before. It's 3. So 3 plus 2 is 5. So the third term is 5. In the fourth term, we say it is f of 3 plus 2. What's f of 3? It is 4 plus, so it's 5. 5 plus 2 is 7. So this is, you just need to write down this. And you say the answer is 7. So f of 4 is 7 here. That's all. This is the procedure of working this algorithm. That's how this algorithm is working. Okay. And it's the end of this chapter. Let's take a break for 10 minutes. Then we start chapter 2. We now have chapter 3. Chapter 3 is about counting methods and probability. And here in this chapter, we have 3 parts, which are counting methods, combinations and permutations, and also probability. Okay, first we have counting methods. We say for the basic counting methods, basic counting principles, the counting principles is all about choices we might take given many possibilities. That means we are going to find all the possibilities to do something. Okay? It's used to find the number of possible outcomes, how many outcomes that you have in doing something. It provides a basis of computing probabilities of discrete events. Okay? So for basic countings, here we have some problems. We have 4 problems. We just provide these problems. We are not going to solve them now, but later on in the next slides, we are going to solve problems like these. Here we have sample of counting problems. Problem 1, it says, how many ways are there to seat n couples at a round table such that each couple sits together? We have a round table and n couples. How can we seat them around the table such that each couple beside to each other? Okay, this is about finding the number of ways, the number of arranging the couples around the table. Problem 2 says, how many ways are there to express a positive integer n as a sum of positive integers? For example, we have 7. We have 7. In how many ways can I write down 7 as the sum of 2 integer numbers, 2 positive numbers? Okay. This is about finding the number of ways to write down n as the sum of positive integers. In problem 3, this is only the type of problems which are in basic counting principles. It's only the type of problems. We are going to solve some problems about it later on. Here, there are 3 boxes. We have 3 boxes containing books. The first box contains 15 mathematics books by different authors. And also, the second box contains 12 chemistry books by different authors. And the third box contains 10 computer science books by different authors. A student wants to pick only one book. Okay? From one of the 3 boxes. Here, there are 3 boxes. In one of the boxes, there are 12 books. In the other one, you have 15, and the other one, you have 10. In how many ways can the student pick a book? Finding the number of ways is counting principle. It is count. Here, we solve the problems like this in this chapter. And also in problem 4, it says the department will award a free computer to either a computer science student or a computer science professor. How many different choices are there if there are 530 students and 15 professors? So in how many ways are there to give this computer to one of them, to a professor or a student, such that we have 530 students and 15 professors? It's also about finding the ways of the number of ways. Basic counting principles, we have 2 types. So addition principle and multiplication principle. We have 2 counting principles: addition principle and multiplication principle. For the addition principle, we say at this time we can use addition principle. Now, here for addition principle, we suppose that tasks T1, T2 up to Tk, if you have k tasks, these tasks can be done in N1, N2, up to Nk ways, respectively. That means task 1 can be done in N1 ways, for example, 10 ways. And task 2 can be done in N2 ways, let's say 4 ways. And for each task, we have N1, N2, up to Nk ways of doing it. We say if all tasks are independent, that means if none of them depends on the other one of each other, then the number of ways to do one of these tasks is N1 plus N2 up to Nk. Here we are going to write the sum. We are going to write down the sum of all ways. I mean the sum of ways for each of the tasks. For example, task 1 can be done in 3 ways. Task 2 can be done in 4 ways. Task 3 can be done in 10 ways. Here, for doing one of them, is the sum of all ways, which is 3 plus 4 plus 10. It's like that. We say if a task can be done in N1 ways and the second task in N2 ways, and if these 2 tasks cannot be done at the same time, then there are N1 plus N2 ways to do either task. Here, in solving the problems, it will be much clearer. We have an example. In solving the examples, it is easier to understand. In this example, it says, how many ways to find the number of integers between 5 and 50 that end with either 1 or 7? Either 1 or 7. That means here, we should first write down the numbers between 1 to 50, which end 5 to 50, which ends either 1 or 7. Let's first write down, let's say T1. T1 is the numbers ends with, let's say 1. What are the numbers from 5 to 15, which ends 1? Which ends with 1. 11. What else? 21. Then 41. So 31 and 41. ليه قالت شيء؟ چون ژمارەی هەڵبژێرم لە 5 تا 50 بە جۆرێک کۆتاییەکەی یان یەک بێت یان حەوت بێت. کاتی دێم چێکەم؟ لیستی ئەو ژمارەیان کە کۆتاییەکان بە یەک دێت یان نووسم لە 5 تا 50 چیم هەیە کۆتاییەکەی پێک بێت یان 21 31 41. ئەو ژمارەیان کۆتاییان بە حەوت دێت حەوت خۆیەتی حەڤەیە 27 37 47 5 ژمارە. باشە لێرە ئەڵێن ژمارە ڕێگەکان چین بریتە لە کۆی هەردوو ڕێگەکان. لێرە ئەمە بە چەند ڕێگە توانم ژمارە هەڵبژێرم کە یەکی کۆتاییەکەی بە یەک بێت. Here we have 11, 21, 31, and 41. In how many ways can I pick a number with ends with 1? 4, because we have 4 numbers here. We are going to choose among 4 numbers. That means we have 4 numbers. It could be 11, it could be 21, it could be 31, and it could be 41. That means here, N1 equals 4. And for task 2, T2, the number ends with 7. What are the numbers ends with 7 from 5 to 50? 7, then 70, 27, 47. How many are they? How many numbers do you have? 5. So N2 is 5. Here, these two tasks are independent to each other because none of them depend on the other one. None of them depend on the other one. That means the number of ways to pick a number ends with either 1 or 7 is 5 plus 4. That means n equals n1 plus n2. So n is 9 ways. That means here we have 9 ways to pick a number from 5 to 50 ends with 1 or 7. Because it says from 5 to 50. It's not in that range. That's why we didn't write down one. Okay? And here it's written down here. This is N1. This is N2. So N1 plus N2 is 4 plus 5, which is 9 ways. That means we can pick a number from 5 to 50 such that it ends with 1 or 7 in 9 ways. We have 9 ways to do that. And this is the problem that we talked about before. Here, it says a student wants to take a book from one of the 3 boxes. Here you have these 3 boxes. Box of mathematics, there are 4 books in it. For chemistry, we have 2 books in it. For computer science, we have 3 books in it. In how many ways can the student do this? That means in how many ways can the student pick a book from these 3 boxes? Here we have, yeah, this N1. N1 is 4. N2 is 2. And N3 is 3. That means N equals N1 plus N2 plus N3. That means it equals 4 plus 2 plus 3, which is 9. That means the student can do this in 9 ways. The student can do this in 9 ways. That's the T1 is the choosing a mathematics book, which is 4 ways. T2, task 2, choosing a chemistry book in 2 ways. And for computer science book, 3 ways for task 3. So the number of ways is the sum of all ways. 4 plus 2 plus 3, which is 9 ways. We now have another example. It said there are 8 male students and 21 female students in discrete structure class. That means male is 8 and female is 21. Among all of them, 7 students are Chinese. So Chinese, 7. And rest, that means all the other nationalities. Sorry, the rest are Malaysian. Malay. Look, how many students do you have in the class? It's 29. 7 of them are Chinese. Look, from the first given information, it says 8 male and 21 female. That means all the students in the class are 29. Okay? 7 of them are Chinese and the rest are Malay. Okay, Malaysian. That means how many Malaysian students do we have? Look, we have 29 students. 7 of them are Chinese. So what's the rest? It's 22. 22 of them are Malay. Look, the sum of these two must be the same as the sum of female and male students, which is the same. And here, we should find 2 things. First, in how many ways can we select a student, a boy or a girl? We just pick a student. We just select a student as either boy or girl. We say T1, girl, students. That means here N1 equals as 21. T2, boy students. N2 is 8. So here we say N1 plus N2 is 29 ways. So in 29 ways, we can select a student from the class. In the second one, it says, in how many ways can you select a student, a Chinese or a Malay? The same, because let T1 to be the Chinese students, which is 7, N1 is 7, and T2 to be the Malay students, which is 22. 7 plus 22 is 29. So in 29 ways, we can select a student to be Chinese or Malay. That's the solution. Okay? In both, you get 29. Is that easy? Now we have multiplication principle. In multiplication principle, you should recognize the problem as either doing it by addition principle or multiplication principle. For the addition principle, we said if we have two independent or two or more independent tasks, if the tasks are independent to each other, in that case, we use the addition principle. Okay. And for the multiplication principle, we say we suppose that a procedure can be broken down into two successive tasks. Look here, we are going to have two successive tasks. Okay, successive tasks. If there are n1 ways to do the first task and n2 ways to the second task, after the first task has been done, that means task 2 is going to be done after doing task 1. Task 2 is gonna be done after task 1. Then we have n1 times n2 ways for doing this. What we do is say a task T can be completed in k successive steps. That means we have all steps each after the other. Step 1 can be completed in n1 different ways. Step 2 can be completed in n2 different ways. Look, in step 1, we pick, let's say, something in among something else. Okay, we are gonna pick one from them, and then we again pick another one, then another one, like that. So here we have k steps. If we pick k things, or if we have k tasks, then the number of ways to do this is n1 times n2 up to times nk. That means we are going to multiply the ways for each task here. But for the addition one, for the addition principle, we said we are going to find the sum of them. But here we find the multiplication. In the example, it's much easier. Look, this is an example similar to the previous one. But the questions are different. Look, here it says there are 8 male students and 21 female students in a discrete structure class. Among all of them, 7 students are Chinese and the rest are Malay. That means here, girl, boy. Girls are 21. Boys are 8. For Chinese, 7. Malay, 22. You found this before. Okay. Look, it says in how many ways can we select 2 students? But in the previous example, it said 1 student, pick a student, 2 students, a boy and a girl. Okay. In this case, we must use multiplication. We must use multiplication. That means we say if T1 to be boys, T2 to be girls. So N1 here equals to what? 8. And N2 equals 21, because here we have 21 female students in the class. And we have 8 students in the class. That means here, so the number of ways to choose a boy and a girl. A boy and a girl. We said equals 8 multiplying by 21. 8 times 21. So N1 times N2. We don't say N1 plus N2. Okay. It equals to 8 times 21, which is 168. Is it? Yes. It's 168. That's for answering the first question. In the first question, it says, in how many ways can we select 2 students? A boy and a girl. In the second question, it says, in how many ways can you select 2 students, 1 Chinese and 1 Malay? Yeah, we choose 2 students. But in the previous example, it was about addition principle. It said pick a student, choose a student, only one student. But here we choose two students. As you see here, we have two successive tasks in task 1 and task 2. We choose two students. That's why we say this is multiplication principle. Look, we say if we have successive tasks, we have successive tasks. In this case, we use procedures. For example, if you have a box, if you pick some, let's say if you have cards in a box, if you pick, let's say 3 cards, each one after the other, okay? In this case, we use the multiplication principle. But if only one, that's addition principle. Okay? If you pick only one, it's the same. In the class, we have 8 boys and 21 girls. 8 boys and 21 girls. We select a student. If we just select only one student, if we have no successive procedures, I mean, we have no successive choices, we say we use the addition principle. But if we have successive ones, if we choose 2 students, if we choose 3 students, in this case, we use multiplication principle. And here, for the second one, how many Chinese do we have? 7. This is N1. How many Malay do we have? 22, which is N2. We multiply these two to get, we multiply these to 100. 54. It's 154. So we have, as it's solved here, we say T1 to select a boy was 8 ways. T2 select a girl was 21 ways. The number of ways is multiplying these two is 168. And for this one also, 7 times 22 is 154 ways. Okay, you should write down like this in the exams. Okay, write down T1 and T2. Here you have 2 successive tasks. Each one is after that. We have an example here. It says Morgan is a lead actor in a new movie. Morgan is a lead actor in a new movie. She needs to shoot a scene in the morning in Studio A. Let's say this is Studio A. An afternoon scene in Studio C. Let's say this is C. Let's say this is Studio A and this is Studio C. She looks at the map and finds that there is no direct road from Studio A to Studio C. Here, Studio B is located between studios A and C. Morgan's friends, Brad and Jennifer, are shooting a movie in Studio B. There are, look at this. There are 3 roads, say A1, A2, A3, from Studio A to Studio B. Look, from Studio A to Studio B, we have 3 roads, 3 different roads from A to B. Let's say this A1. It's A2, and this is A3. We have these 3 roads from A to B. That means going from A to B, how many choices do we have? 3. No, sorry, from A to B first. From A to B, we have 3 ways. We have 3 ways. Okay? And it says 4 roads, say B1, B2, B3, and B4 from Studio B to Studio C. That means from B to C, we have 4 ways. Look. So in how many ways can we go from A to C? In how many ways? Yeah, we should multiply. Why don't we add? Because the second one depends on the first one. Okay, from first we go to the second. Look, from studio A we go to studio B. Then we go to studio C. These are depend to each other. That means going from A to C, here we have 3 ways. In 3 ways, we can go from A to B. And in 4 ways, we can go from B to C. And multiplying them, we get 12 ways from A to C. From A to C, we can do it in 12 ways. This is the diagram here. It says task 1, let's say 3 ways from studio A to studio. Task 2, we have 4 ways from studio B to C. So in how many ways we can go from A to C? We just multiply these two. It's 3 times 4 and 12. We have 12 ways to go from A to C. We have another example. It says the letters A, B, C, D, and E. We have 5 letters. A, B, C, D, and E. We have 5 letters. Are used to be used from to form a string. To form strings of letters of length 4. That means here we use these 5 letters to create strings of length 4. That means each. I mean, we are going to make words by using these 5 letters. And each word must have only 4 letters. Each word must have only 4 letters. It says, how many strings can be formed if we do not allow repetitions? That means we cannot use A twice, or for others the same. For B, C, and C, D, and E. We cannot use repeating letters in a word. Look, for a word, for one word, if we pick the first letter, in how many letters do we choose the first one? Look, if let's say we have A, B, C, D, E. If we choose a letter here, how many ways do we have? 5. So to choose the first letter, choosing the first letter is 5. After choosing the first letter, 1 letter is reduced. Let's say C is reduced. Let's say that. So now, how many letters do we have? 4. So the second letter, we choose from 4. The third letter, let's say we choose this one. We have 3. And the fourth one is 2. That means here we choose or we pick the first letter among 5 letters. After choosing the first letter, we cannot choose that letter again. That means we remove that letter in the box among the letters. And then for the second one, for the second letter, we choose from 4. From 4 students, among 4 students, we pick it. After picking the second letter, again it's reduced by 1. So we get 3 letters now. To choose the third letter, we pick it from 3, and then for the fourth one is 2. So this is the procedure. I'm gonna write down here. Look, to choose the first letter, we have 5 ways. Okay? In the box, we have 5 letters. After choosing the first one, this letter cannot be used again. That means we remove this letter from the box. And then for the second letter, we have 4 ways. Why? Because now we have 4 letters in the box. And so on for 3 and 4 letters. Now we have these 4 tasks. Since we have successive tasks, letter كرداري كدوا بدو أكمان عشان تاسك كدوا بدو أكمان كواتا شيء وكارين like that. Here we use multiplication because we have successive tasks. Task 1 is 5. So here we have n1 is 5. n2 is 4. n3 is 3. And n4 is 2. We just multiply n1 by n2 by n3 by n4 and we get 120 strings. That means here we can create 120 strings in the condition that we have no repetitions. If there is no repetition, we can create 120 strings. So in 120 ways we can create strings from those 5 letters. And this is the same example, but here we are allowed to use the repetitions. If we have the box with A, B, C, D, and E. We have these 5 letters in it. So for the first letter, we choose the first letter from 5 in 5 ways. How about the second one? It's still 5 because repetitions are allowed. So it's still 5. We don't remove any letter from the box because here we allow to use the repetitions. That means, how about the third one? Fourth one, 5. 5 times 5 is 25. Times 5 is 120. Times 5, 125 times 5 is 625. We have 625 strings. Okay? So we have 625 strings if repetition allowed. Okay? Now we have run the example. We just talk about this example and it's enough for today. We have 5 letters, A, B, C, D, and E. These 5 letters are used to form strings of length 4. That means each word contains 4 letters. Each word contains 4 letters. That's why we say task 1, task 2, task 3, task 4. If it's 3 letters, we just have task 1, task 2, and task 3. That's all. It says in how many strings begin with A? Begin with A. If repetitions are not allowed. Look. For the first task, the first letter must be 1. The first letter must be A, sorry, not 1. The first letter must be A. That means we just pick A from itself. That means we have only one way to choose the first letter, which is A. So T1, we have first letter. This we have one way. We have only one way because it says it must start with A. That means you have only one A, and when you pick it, that's so. So here we have only one way to choose the first letter. How about task 2? To the second letter. Look, in the box we now have B, C, D, and E. We have 4 letters. In how many ways we can pick the second letter? 4, because we have 4 letters in it. Now it says repetitions are not allowed. That means we must reduce one of them. بلام على أبي هريك هر أي نال هر كامل شن حاط ما هي بو هرجاني أي يك أبي هر أي بيت واي وتوا okay بلى نابي يعني. So here how about T3, third letter? We have 3 ways. And for T4, which is fourth letter, is 2 ways. Now we multiply these all to get the number of ways to create letters starts with A without repetition. So what if the repetition allowed? What if the repetition allowed? In how many ways can we choose the first letter?
Only one.
Yes, it's still 1. N1 equals 1 way. How about the second letter?
5.
Yes, 5. Because the second letter, it could be A also. It could be A. That means here we have A, B, C. Sorry. I'm saying if it's allowed. If it's allowed. We talked about if it's not allowed. But if it's allowed, we say we have 5 letters. For each one, except the first letter. For the first letter, we have only one choice. We have A. It's because it says it must start with A. So here, we say for the second one, we have 5 ways. How about the third one? It's still 5. For the fourth one, that's all. Now we multiply this, we get 125. That means if the repetition allowed, we have 125 strings. We get 125 strings. That's for the repetition if it's allowed. If it's not allowed, it's solved here, and also we talked about. That's solved. And we talked about it. Now we have applied basic counting. It's enough for today. For tomorrow, we start that part of the chapter.